Welcome back to 10 Applied Math. Today we're on day 3 of solving linear systems using the method of elimination. So on the first day, we were using the idea of adding the equations together to eliminate either the x or y variable. And on day 2, adding would not eliminate one of the variables, so we had to use subtraction to eliminate either the x or y variable. And today we're going to be solving linear systems, and you're going to have to decide whether you actually are required to add or subtract the equations to eliminate one of the variables. And at the end of our last video, I actually left you with a question. I said, what are the conditions that need to exist in order for you to add the equations, and what conditions must exist in order for you to subtract the equations? How do you know? Do you add or do you subtract to eliminate one of the variables? It's now up to you to decide. Now, what I've done is I've summarized for you, hopefully, what you came to, the conclusion that you came to on your own. So in order to eliminate the x or y variable, we are going to either subtract or add the rows together, the equations. If we encounter like terms, meaning the x terms are identical in both equations, or the y terms are identical, meaning that they are alike, then we will subtract the equations to eliminate one of the variables. If we encounter opposite terms, meaning we have an x term and a y, two x terms that are opposites, meaning one can be a positive 2x and one can be a negative 2x, then we are going to add. If the y terms are opposite, meaning one's positive, one's negative, same number, but just opposite signs, then we are going to add. That's what we need to do. So let's look at some examples. So before we actually solve, we have to decide whether we're going to add or subtract. And to do that, we are going to compare the terms. So looking at example 1, we can see that we have a 4x here and we have a negative 4x. So the x terms are opposite. They are opposite. And because they are opposite, this tells us that we need to use addition. We are going to eliminate variables by adding those together. So I'm going to get out a ruler, and I'm going to call 1a and 1b, and I'm going to proceed to add these together. So 4 plus negative 4 is going to give us 0x, 5 plus negative 3 is positive 2y, negative 10 plus 14 is positive 4. So we have a plus b. We now have a 0x, which means we have eliminated the x terms. So 2y is equal to 4, so y is equal to 2. Then to find y, we are going to substitute y equals 2 into either equation A or B. It's your choice. I'm going to choose A. So we'll have 4x plus 5, replace the y with a 2, and then we're going to do the multiplication, and then I'm going to isolate the 4x by moving the positive 10 to the opposite side, so I'm transposing. I gather like terms, and then I divide both sides by 4 to get x is equal to negative 5. So our solution is xy equals negative 5 and positive 2. That should be the answer. This point should belong to line A, and it should belong to line B, and you can go through the process of doing formal left side, right side checks. So let's move on to example B. So looking at the x terms, we have a positive 1 and a positive 2 as our numeric coefficients. They are neither like nor opposite, so then we proceed to compare the y terms. A positive 1y and a positive 1y, they are like terms, so that means we are going to subtract the equations. I'm going to draw myself a line. And I'm going to take equation A and I'm going to subtract B. So that'll give us minus x plus 0y equals 7. Negative x equals 7. So x equals negative 7. Then we're going to substitute that in. Substitute x equals negative 7 into, I'm going to choose A again. So we're going to have negative 7 plus y equals 12. Y will equal 12 plus 7. So y equals 19. So our solution is going to be the ordered pair negative 7 and 19. And we can go through and do a formal check. We didn't do that on the first one. Let's do a formal left side check. So for equation A, the left side is x plus y, which will be negative 7 plus 19, which is equal to 12. And the right side was also 12. So we have verified that the left side and the right side are equivalent when we use these x and y values in the equation. And we do the same thing for equation B. The left side will be 2x plus y, which will be 2 bracket negative 7 plus 19. Negative 14 plus 19 equals positive 5, and our right-hand side was 5. So I am now confident that I have the correct solution because both equation A and equation B are satisfied when we substitute in the x and y coordinates. Okay, so we're going to look at one last example using the method of elimination. So when I look at this, I start by comparing the x values. And so my x values, my x terms are the same. So because we have like terms, we can subtract. So option 1, I'm saying option 1 because I'm going to explain, is if we subtract, we will eliminate x. But if you're looking ahead and you're saying, well, let's look at the y terms, you're going to notice that the y terms are opposite. And because they're opposite, if we add them, we would then eliminate the y terms. So in fact, in this case, you have two options. You have the option of adding to eliminate the y terms, or subtracting to eliminate the x variable. So you have some choice here. They're both correct. So I'm going to add. I just think it's easier to add. So when I add these together, I'm going to get 2x plus 0y equals 8. So I'm going to write down a plus b. So then it's clear that I'm choosing to add. So 2x is equal to 8, means x is equal to 4. So then 4 plus y is equal to 3. I'm substituting x equals 4 into equation A. So y will equal 3 subtract 4. So y is equal to negative 1. Summarize that our solution is the point 4 and negative 1. So what we need to do, just in summary, is to use the method of elimination requires us to either add the equations together or subtract the equations. Deciding which operation to use, either adding or subtracting, requires you to look closely at the terms in each equation. Are your x terms opposite, or even your y terms? If you have opposite terms, you need to add the equations. If you have like terms, then subtracting will eliminate one of the variables. And if you have both like terms and opposite terms, then you have choice.